Hello and welcome. So we're going to be working with some complex numbers, and for this one we're given the complex number w. It's negative 9 plus I. Alright, now this is kind of a tutorial style problem where we'll say, okay, using the complex number, what angle does inverse tangent return? So we're going to be we're setting this up to find the argument. Alright, so when we're using inverse tangent, right, the angle that we're looking for is the angle inside of the triangle. Alright, and the reason why we're using inverse tangent is that when you graph the complex number, right, negative 9 comma 1, negative 9 comma 1, right, when you graph that complex number, you end up in the second quadrant, right, you've gone left 9, you've gone up 1, Pythagorean theorem, if you wanted to find that third side, right, the modulus, to find that last number there, but we don't care about the third side, we're looking for the angle, so we say, okay, this is the opposite side and the adjacent side, and that's why it's inverse tangent. So tangent to the negative 1 of opposite over adjacent. I don't know why I just put 0 there. There we go. Alright, so that is our theta. Now the official setup, in case you're like, how do I know how that was set up? We're saying tangent of the angle is the opposite over the adjacent. Right, undo tangent with its inverse, you take the inverse tangent, okay, of both sides, and that's how we got here, because tangents undo each other, leaves you with theta, right? So we just kind of, I just kind of cut that step out, but that's what we're doing. So if we put this into the calculator, let me come back over here, we say, okay, inverse tangent of 1 over negative 9, booyah. And we see this, and it gives us back a negative angle. I'm just going to round this to the nearest whole degree, makes it a little easier to work with, so negative 6 degrees. And you're like, how do negative angles work? Well, whenever we're doing any angle along the coordinate plane, we start the rotation from the positive x-axis, right? From that right side of the coordinate plane, and then we start rotating counterclockwise, right? Rotations would go that direction. Well, if that's the direction rotations normally go, negative angles, right? Positive angles rotate up, which means negative angles rotate down. Inverse tangent just gave us a negative 6 degree angle. That is the angle if we were to draw a straight line coming from the hypotenuse of the triangle through, right? This angle there is negative 6, meaning this is a 6 degree angle there as well. Okay, and you're like, okay, so that's what it's looking for in the first plane, because it's saying, okay, what is the angle you get back? That's negative 6 degrees. Okay, it literally returns us back negative 6. Okay, and then it says, what quadrant are we in? Well, if you graph it, we're in quadrant 2, right? So quadrant 2, right? Now, inverse tangent, this is kind of a heads up on this, will only return answers back in your first or fourth quadrant. That's why we were given negative 6 degrees, is because it will go a maximum just under 90 degree rotation, right? Either up or down, right? Inverse tangent will not return anything in the second or third quadrant. We're in the second, right? So we got to be careful. That's why we graph the complex number or know where it's supposed to be at, because that helps us figure out, okay, it's negative 6 degrees, but we're not in quadrant 4. We are definitely in quadrant 2. Okay, so then the question is, in order to get to quadrant 2, the argument, what we're looking for is the rotation from our x-axis to the hypotenuse of that triangle. In other words, the modulus, the thing that connects the origin to our complex number. Well, I'd say, okay, well, if I'm looking for that hot pink angle, right? Angle equals what? I know that all the way around, this whole section right there is 180 degrees. Right? That's half the coordinate plane. It's like half of a circle. It's 180. And I know that this is just 6 degrees short of 180. So that means we're doing 180 minus 6 degrees. So 174 degrees is the argument. That is the hot pink angle right there, right? 174 degrees. So when we're looking at this, we say, okay, well, essentially, to negative 6, what number did we add? 180. right? And that gave us the 174 degrees there. Now, what if we weren't in quadrant 2? What would we have to add each time? Well, if you're in quadrant 1, the argument is that hot pink angle, and what's returned from using inverse tangent, you'll notice, is the same thing. It's in quadrant 1, inverse tangent can get you there. So add 0. Yay! Okay, you don't need to add anything onto it, it's literally the answer. If you're in quadrant 3, right? If you're in quadrant 3, so this is quadrant 1, here's quadrant 3, then what's going to happen is that the inverse tangent returns that angle, the argument is that angle there. Well, I know that if this orange angle, right, this orange angle is what I'm looking for, I also know that that's going to be the same angle. So that's going to be 180 degrees plus the angle we get back from inverse tangent. So then it'll be add 180. If you're in quadrant 3, add 180. Quadrant 4 is kind of a weird one. Inverse tangent returns the negative angle. The argument, however, goes all the way around. Well, think about this. What does the orange plus the hot pink make? A circle. How many degrees is a circle? 360. And you know the orange angle is going to be negative, so if you essentially just add 360, you will get the hot pink angle. Okay? So that's kind of like your key for solving these things. Alright, there you go. That's it. That's how you find the argument of a complex number. Thanks for watching.